Hello and welcome. This lab, we're going to be trying to find the specific heat of our unknown metal. Now, when we talk about metals, we're looking perhaps at copper or aluminum or iron, brass, lead. That's where the different groups are going to be coming in, because each group you're going to get a metal. Okay? It has not been determined yet what you're going to get, but we're going to be using something called a coffee cup calorimeter. We've been talking about thermodynamics. The whole point about thermodynamics, if you think about it, is dealing with the energy changes that take place within a chemical reaction. Now, for us here, we're going to be working with calorimeters. Now, we're also looking at Q equals MCAT. This is the formula that I had gone over with you in class, where Q represents the heat. M is the mass of our object. C is our specific heat. And then, of course, the change in temperature, our delta T is TF minus TI. That is where we're going to get our delta T. So this is what we've got here, our basic formula that we're going through, just reviewing. I'm very confident that you guys know what you're doing. And now, all right, on with the idea behind the lab. Well, we are going to have a piece of metal that's going to have a certain amount of mass. So we're just going to say M1 for mass of the metal. We also, we're going to heat it up to a certain temperature, so we're going to give it an initial temperature as well. And on the other side of the coin, we have ourselves our coffee cup calorimeter. Now that coffee cup calorimeter is going to have a certain amount of water. You guys will get to know about that amount of water once we get into the lab. The problems that I've had in the past is if there's too much water, we heat up the metal, put it in the calorimeter, and we don't have a registered temperature change. So we have to be careful. We have to have enough water to see that we can have a registered temperature change. And at this point, I'm probably thinking about maybe doing it digitally. But for now, we're going to work with regular thermometers. So here, we're going to have a certain amount of water as well. We're going to call that M2. And how are we going to determine the mass of the water? Well, if we know the density of water, 1 gram per milliliter, we can put in a certain amount of millimeters into the cup, and then we can determine the mass by it. But we're also going to need to know the initial temperature of our coffee cup calorimeter as well. What's the water in there? So really, there's going to be 2 thermometers involved in this experiment. One is going to be checking the temperature of our heated up metal, and the other is going to be the temperature for our coffee cup calorimeter. So that's what we're working with. Now, I said Q equals MCAT. We were making a big deal about this particular equation. We're heating up this metal, we're going to rapidly transfer it into the coffee cup calorimeter. Are we going to lose some of the heat in the metal as we transfer it from the beaker of boiling water into our calorimeter? Yes, we absolutely cannot avoid that. There's not much we can do about that. However, as we go through, the idea is that once you have the metal in the coffee cup calorimeter, we would expect the temperature of the metal to go down while the temperature of the water in our calorimeter is going to go up as it's absorbing that heat energy from the metal. So the idea is, how do we know when it has achieved equilibrium? When we know that the heat has been exchanged and everything is good to go. Well, the final temperature of the water is going to equal the final temperature of our metal. That's how we know we're going to arrive at equilibrium. Now, once we have that, the idea is this, that there's going to be the energy transfer. We know that the energy transfer will be complete once the temperature has stabilized. When we see the thermometer stopping the rise. Now, this can happen very quickly, so you have to pay attention to it, because for us, it's going to take a while to heat up that metal. With that, we go along the idea that if the temperature is the same, then we would expect that the heat energy of the water is going to equal the heat energy of our metal. That's how we're going to be able to do this. So far, so good? All right. So when we look at it, we're going to look at Q equals MCAT. We know that. So then we're going to look if these Q's are equal to each other. We can turn around and say mass of the water times the constant, the specific heat of the water times the temperature change of the water. So that's going to be our MCAT for the water. That is going to be equal to the mass of our metal times the specific constant, which that's the objective for this lab, to find our specific heat constant for our metal times the temperature change of our metal. That's the idea behind this lab. All right. So now we explained the theory. Now what we need to do is go into the lab itself. I do not have the ability to stop the video and then go and reset up in the lab. So I'm going to have to make this one video, one shot. Okay? So we're going to move over. We're going to move over to the lab next. We're going to take this and we're going on a little trip. And here we go. Going on our trip. Going on our trip. Oop, nobody in the hallway. Oop, Miss Spencer's in the office. All right. Let's move on. Okay. Oop, the lab looks dark, but that's okay because I got the key. We're still running. And like I said, the quality of the assistance is lacking. So excuse me one moment. I need to move my camera over off to the side. I need to grab a chair, another one. And I am sort of making a tripod, if you will, without actually being the tripod. Alrighty. So here we go. We're still running. Okay, so what's the setup going to look like? Well, let me pull it back a little bit. There we go. Okay. Let's double check everything. All right, everything looks in place. And all right, we'll move on. It doesn't matter if you see my face or not. The idea is that this is what the lab setup is going to look like. So each group, you're going to get a heating plate. You're not going to get a Bunsen burner this time around. We're just going to do it with a regular heating plate, a little miniature stove, if you will. We got a beaker. We have a thermometer. We're going to have another beaker. Now it is bigger, but the reason for that is that this is going to be our calorimeter right here. Styrofoam is pretty good at keeping the heat in. We also have a smaller thermometer for this. So, we also, we're probably going to have to work on a system for obtaining the metals, and I'm probably going to be the guy to do that. Now, I use this as an example. Here you can take a closer look. This is a lead weight. It's used for fishing. That works for what we're doing. Now, what about the safety gear that we're going to need? The safety gear that we're going to need, we definitely need an apron because we are working with boiling liquids. Okay, so you got to put on the apron. Goggles, you need to put on the goggles so that you see I'm actually doing it. There you go. All right, what do we need to do? Well, in the instructions, you are going to be told to put in a certain amount of water, and that's where the grad cylinder comes in, and you're going to be pouring it in here, and then you're going to turn this thing on. And of course, making sure that it is nice and plugged in. Now, the idea about this is that we want the water to boil pretty rapidly. I'm going to try to heat up the water before class, but the idea is we want the water to heat up fairly rapidly. what we want to do is take that piece of metal. Now we can weigh the metal, that's not a problem. And we got our balances over there. So then once it's weighed, you can take it and you can put it in here. All right, so the idea is that with the boiling water that we can heat up our metal on the inside. Now we are making an assumption, and that's a big assumption, that this metal in here is going to be at the same temperature as the water that's on the inside. We are going under that assumption. Now, in here, you're going to have your coffee cup calorimeter. What you're going to be doing is you're going to put in, again, a certain amount of water in here, which is why you use this. You do not boil this, you do not heat this up. You can get the water from the tap, that's not a big deal. But this thermometer needs to be in there, and you want to make sure you record your initial temperature. Next thing, you take, once you're ready to go, and this has been boiling for a while, and it's a nice hot temperature, then you got to go in, and this is the next trick, and I'll probably have to give you guys some kind of special hooks for it, where you go and you're going to be picking it up. You're going to take that. This has got to be fast, guys. It has to be fast. You're going to take this and put it in immediately, and then you're going to watch the temperature change on this thermometer here. Now, if necessary, we can switch thermometers. That's not a big deal. All right? So, once you got the temperature at an equilibrium, once the temperature has stopped changing, okay, then you're basically done. You can shut this off. You can take the metal out if you wish. You can take the metal out, and then we can go ahead and do the calculations. At this point, ladies and gentlemen, we're done for this lab. That's the whole basic idea behind the lab. So you need the review, quick review. You need your safety gear. You need apron. You need goggles. We're working with glass. We're working with boiling liquids. We're going to have 2 thermometers, one to measure the initial temperature of our piece of metal that's going to be on the hot plate, and the other is going to be measuring the water in our coffee cup calorimeter. When I say coffee cup, I really meant coffee cup. Now, I put the styrofoam cup in the bigger beaker to provide stability, that it's less likely to tip over for the water. You also have your graduated cylinder that we're going to be making precise measurements of the amount of water that you're going to need, the chunk of metal that will be assigned to you, and then something to get the metal out of here when it's nice and hot and put it in here. All right, that concludes the video. All right. Any questions, ladies and gentlemen, at this point? Well, I don't think you can really ask questions, but we're done here. Take care.